All right. Hello, everybody, and welcome to the stream. Hope everybody is doing well tonight. It looks like we have a slight display issue here. Let me just resolve that really fast. Let's see. Thinking it's probably my cam link isn't picking up correctly for some reason. So let's actually just switcheroo on that real quick. There we go. Sometimes I have to refresh it. It's weird. Anyway, so welcome to the stream. I hope everybody's doing well tonight. Tonight we are actually going to do serialization / deserialization, as opposed to last time where we spent most of the time doing a deep dive debugging session. And so the good news is I actually have a lot of this stuff working. I was able to get some stuff done offline. So we're going to quickly kind of talk over that, and then we'll jump right back into it. I do want to take a quick second and just thank the supporters of the channel listed here on the screen, beginning with our partners, who are the highest tier of subscription over on Patreon and YouTube memberships. They are Gabby Bashir and Gerbolis Inc. Thank you very much for that. I would also like to thank all the other supporters listed here on the screen. They are a combination of the other tiers of subscription on YouTube memberships, Patreon, and Twitch subscriptions. So thank you all very much for your support. It is greatly appreciated. With that said, I'd also like to extend a thank you to each and every one of you viewers, whether you're here on the Twitch side or over on the YouTube side. We do simulcast. I'm pointing because I have the chats up on different monitors to the side here. So we do simulcast. I do watch both chats to the best of my ability. And as such, we will, do the best that we can to keep track of them both. So, Raz, hello, how's it going? Elite Braillex, first time chat, welcome to the stream. Weird Trash Can, good to see you. You got hacked on Twitch and your account was banned. Oof. Hope no one clicked the link the hacker was sending. I don't know if that actually happened on this channel or not. Yeah, I don't remember seeing a link. But yeah, did you wind up setting up like two-factor authentication so you don't have that happen anymore? Because I would definitely recommend setting that up if you don't have it. But I'm glad you got your account back. That's definitely, that's crazy, right? Hope that doesn't happen to you again. HPN, first time chat as well. Welcome. Hope you're doing well. You've used two-factor authentication for years. You don't know how that happened. Weird and disturbing. That's not great. I wonder if it was like cached in your browser or something and somebody just hijacked the session. That's another thing that can happen. Weird. HPN, thank you for the follow. Appreciate that. Okay, so where we left off last time was we had basically done a deep dive debugging session and didn't wind up actually having enough time to handle the deserialization that we needed to do. We did resolve the bug. We found the bug last time, and we started kind of talking about it a little bit, but we didn't actually get there. So the good news is I've done some of the work off camera, so we can just kind of take a look at what I've done and go from there. And we just have a few more things to figure out, and we'll be good to go with deserialization, and then we can start looking at serialization. So just as a review as to what exactly it is that we're doing, we have this file here to the right, and this is essentially a scene configuration file using our custom parsing that we wrote for our custom language. It's very similar to JSON, but it's not exactly the same as JSON. And so we have a system set up that will tokenize this whole file, parse it out, and then we can use that tree of tokens to actually extract the data out of this, right? And so we've got ahead and done that, and now it's just a matter of actually making use of that. And the goal is to basically be able to deserialize this file into a scene configuration. And we also want the ability to reserialize a scene back into a configuration that can be written to this file, right? That's the ultimate goal. So in other words, if we load up this particular scene, we also want the ability to be able to, maybe move the position, change the color of a light, something like that. And then be able to save the scene and have it write out to a file that looks like this. The only difference is going to be this file format does support comments. Obviously, when we write that out, those comments will be gone, and that's okay. But that's essentially the goal, right? Maybe some service linked to your account, could be. Yep. It's entirely possible. If somebody like hijacked an authentication token, right? Or again, session hijacking is a thing. Okay, so where we actually need to look for this is going to be the scene loader, if I can spell it right. And we have a few things here. We have, let's see. Did I not pull latest? Noob mistake. Yep, I didn't pull the latest code. I actually did this on my laptop, so I didn't actually have the code pulled. That's pretty sweet, huh? All right, so there we go. That's what I was expecting to see. So essentially what we've done is I'm actually going to skip past some of this stuff and go to the bottom here. Okay, so our entry point into our deserialization is basically going to be this deserialize case and method, right? And so this is going to be deserializing a single node in the scene. And that's sort of the entry point. We're going to come back and review all this logic and so forth. But we also have this scene config deserialize casein, which is sort of a top level function that gets called that reaches in and deserializes all the different objects in here. And so if we skip down below that a little bit, we've got a bunch of dead code in here I think I can actually get rid of. We have our scene loader load. Now, before what we were doing is we were essentially opening a file handle, taking a copy of the full path, checking out the file size, looking or reading all the text in, and then closing that file. We did some light verification here on the bytes read versus file size. There is a mismatch there because of the carriage return new line on Windows. But then we go ahead and we parse the file, right? So we have this casein tree from string function that gets called. And that takes this entire thing, tokenizes it, and turns it into a casein tree. For a refresher, the casein tree has a single object root, right? This always exists no matter what the scenario is, right? So this may be empty. It may not have anything in it. And if we peek the definition of that, the only thing an object has is an object type. So an object can be an array or an object, right? So in the context of this file over here, properties here is an object with properties in it, right? Nodes here is an array with objects in it. Each of those objects has properties. One of those properties is an array of further objects, right? So that's kind of the way that we recurse down through as we're trying to deserialize all of this, right? So basically all an object contains is its type and then a array of properties. As a quick refresher, a casein object and a casein array are the same thing. You'll notice that down here we have a new type def that I added just for a little bit of clarity, right? So a casein array is just a casein object. The only difference is these properties here, each property has several fields, right? So we have a type, so that would be like string, integer, float, and so forth. It has a name, potentially, and then it has a value, which is a union here. We also split this out into its own type, right? So a property value can be an integer, a float, a string, another object, or a Boolean, okay? So the only difference between an object and an array is that an object has named properties and an array has unnamed properties. So what that means is if we take a look at this object here, right, it has two properties. One of those properties is named type with a value of skybox. The second is named cube-map name with a value of skybox, right? If we look at an array, such as this attachments, right, we have a property here, which is just an object, but there's no name attached to that, right? It's just an array of objects. The type of properties in here can be mixed, so we can have like the first element in an array can be an object, the second one could be an integer, the third one could be a string, etc., right? So we can mix and match those if we wanted to for some reason. And so that is essentially the way that all of this works, right? That's the main thing to keep in mind. So our Caisson's tree is always created with a root. That root can have properties. It can also have other properties that are objects, so on and so forth, right? So we are going to essentially step through from the top level of this file all the way down through all of these, right? And we're just going to recurse all the way through. So when we talk about deserialization, you can kind of think of the entire file itself as an object, right? And that object has named properties, right? The first one of which is properties, right? The second one is named nodes, right? And so these two properties belong to this root object, right? So that's kind of the way that we handle those. Okay, I hope all that makes sense. Let's see. I'm new in programming, just started college, but I'm really interested to understand low-level code. Do you have any books recommendations? Yes, I do. So, what did I do with... I don't have my... One of the ones that I always recommend, that is a decent primer on some of this stuff, is Game Engine Architecture by Jason Gregory. I don't have the actual book here. I don't know what I did with it. I think it's downstairs, and I keep forgetting to bring it back up. But then there's also this book, which is Sam's Teach Yourself C in 24 Hours. That's 24 cumulative hours, not like you learn C in a day, right? And that's a decent primer on how a lot of that stuff works. And then there's also... I have Effective C++, which is a book. There's also an Effective C book, which is another good book to read. Those are the ones I would probably recommend starting off with, for sure, because they will... C is a low enough level language to give you a good understanding of how computers work, right? So that's usually the language that I suggest people start with if they're wanting to do low-level stuff. So I hope that helps. Taman, good to see you. I'm doing well. How about you? Good to see you, bud. Welcome. All right. Okay. So we parse the file. We allocate this scene config memory, right, which is going to hold all of our data. And then I guess let's just quickly review what that looks like as well, right? So the scene config itself has a version, which we're not actually currently handling that. We should probably handle that. That indicates the version of the scene / the version of the scene file format that we're dealing with. So we eventually will want to handle that too. We didn't bother because the first iteration of our scene file was sort of a flat INI-like structure. And so I'm not even going to count that as a version, right? That was just something temporary we did to get something up and running. So we'll likely start this at version 1, and then every time we make a increment to the capabilities of this format or add something to it after this point, we'll increment that number. And that'll tell us what properties are supported and what properties aren't supported per version to allow us to have backwards compatibility from this point going forward, right? Next stream will be on the treadmill churno style. You know, that's not a bad idea actually for a point redeem. I'm gonna write that down because I know you didn't bring it up as a point redeem, but I do have a standing desk, and one of the point redeems in there is to make me stand for half an hour. So, yes, that could be a thing, right? You're on to something there, Taman. It is a good idea, right? Yeah. So thank you for that. Okay. Where was I? Okay. So that's the version. Each scene can have a name and a description, as well as a listing of nodes, right? So this kind of a little bit lines up with what we have here, right? So nodes can be listed or nested inside of other nodes. So if we take a look at our nodes themselves, each node can have a name, and then they can optionally have an X-form or a transform, right? And it's optional. So if we take a look at this node here, this environment node, it has attachments, which we haven't gotten to yet, but you'll notice it does not have an X-form. But if we come down here to this Sponza node, it does have an X-form, right? And its child, the tree here, has an X-form as well, right? So X-forms are optional. And then if there isn't an actual X-form available for like a parent node or something like that, it'll try and go all the way up the tree to find one. And if it still doesn't find one, then it'll just use the X-form locally, right? So that prevents us from having to have useless transforms on nodes that don't really need them. So for example, this environment node has a skybox. Skybox doesn't need a transform. We have a directional light. The directional light doesn't need a transform, right? So none of this stuff here needs a transform, so we don't give it one. Okay, so the next thing we have is a D-array of attachments, a dynamic array of attachments, right? So we have the configs for those. So attachments are like this thing here. We have different attachment types. So we have a skybox attachment, a directional light attachment. We have a static mesh attachment, and then we have a point light attachment, and we have a terrain attachment, right? So all those different attachments have different attachment configs associated with them. And those can be tacked onto a node as many as you want. And then as we mentioned before, nodes can have other nodes as children, right? So if we come up here, we build out configs for the X-form if it has one. And then each attachment has its own config, right? So we list off the type on that attachment and then the actual attachment data, which is filled in with one of these guys. So we have one for point light, one for directional light, one for spotlight, skybox, one for terrain, and one for static mesh, right? And then we have those attachment types here. So we use all of these. This is basically what we scaffold our scene configuration out of. And our scene is already set up to actually accept all of this stuff. And so we are basically converting from this file format into a structure or a nested structure of these things, right? Let's see. When do I usually live stream? Wednesdays and Thursdays. And yeah, sometimes on the weekends, but that's like an extra stream when I have time to do it, right? It's definitely not a common thing. But yeah, the official time is Wednesdays and Thursdays, starting at 9 p.m. Eastern Standard Time or Daylight Time now. Sometimes I'd like to start a little bit early if I can, right? And yes, Taman's correct. There is a Discord server where there's announcements in there when I go live. Oh, we have another Brazilian. Nice. Yeah, if you guys wouldn't mind just keeping it to English, though. I know, Elite, I know you're new, but I unfortunately don't understand Portuguese, but I do appreciate it because I know there's a lot of Brazilians in here. Maybe that's on the list of my languages to learn. Who knows? I could probably only tell you bad words anyways, which I'm not going to do on stream. Anyway, so when we do our scene load, we build out our case and tree, right, which gives us our list of objects. We allocate this, and then we deserialize the scene with a single call to scene config deserialize casein. We pass it the source tree that we got from the parser, and the resource data, which is the scene config that we're going to build out, right? And if that is successful, then we go ahead and we clean up the source tree, set the data, the size, all that, and return true from the loader. If it fails, we bleat about it, clean up the tree, return false, right? You managed to pronounce my username correctly. I was impressed, to be honest. Awesome. Yeah, anteater in a suit. Yeah. Cracks me up every time I think about it. All right. So we're going to take a look at this guy. And we'll get a general feel for how we decompose these properties or these objects into what we're looking for. Okay. So the first thing that we do is we extract the scene properties. So that's going to be this guy here, right? So we say that's an object, right? So we want the scene properties object. So we reach into the root and we say, give me the property value as an object for something called properties, right? So what that does is it says, hey, scene root, look through our properties, which is there's one here, and I think that's actually it. So there's only 2 of them in this case, right? And it says, give me the one that's named properties. So this literally just goes through and checks the strings for each one until we find one that is called properties. And you might say that that's slow, right? But this is only during when we're actually loading a scene. So it's not really that big of a deal, and we can multi-thread this if needed. And so we do that. We pass it the scene properties object here. We pass the address of that. And then if we, for some reason, weren't able to get that, we bleat about it and use some defaults, right? Otherwise, we extract the name and the description. So we do that by saying, hey, casein object, give me the property value as a string for the thing called name, right? And that gives us name. And then we take a duplicate of that name, right? We do the same thing for description. So it says, hey, give me the property called description, give me its value as a string, right? And there is some basic type checking in there to make sure that you're not actually trying to call a property type that isn't valid, right? So if we have a little bit of time, we'll step into that as well. Okay. So that's essentially the way that these 2 things are brought into the scene properties. Now, the interesting part is the nodes, right? So we always create the nodes D-array. Even if it's empty, we create it. That way we can just look at it and say, hey, how many are there? Maybe there's none, right? And that's our scene. That's certainly a valid use case. And it's one that might exist for like prefabs and stuff like that. Hint, hint about more features coming. So the next thing that we do is we extract and process nodes. So the next thing we do is we get the scene nodes array. And that is saying, hey, casein object, the root, give me the property value as an object. Now remember I said objects and arrays are the same thing, right? And it says, give me the one for nodes, right? And then it checks here to make sure that it's an array, not just an object, right? And so if for some reason it does not find a array, but it finds an object, we bleat about that. Otherwise, we get the count of those nodes. So we say, hey, how many nodes or how many properties or elements do we have in this array, right? And we're going to call that node count because that's what it is. And so we have a field or a function here to get that, and then we loop through each one of those. We set up a new node config for each one of those. And then we go ahead and we get the casein node object, right? So this is going to extract the casein object for the first node, right? So that basically includes this whole thing here, okay? So we get that, and then we say, hey, let's go ahead and deserialize that casein object, right? Which will recurse down through it. So if we go into this guy, We do some sanity checking here just to make sure that we actually have valid pointers to stuff, that the object type is actually an object. And then we do things like we grab the name, if the name exists, right? If the name does not exist, then we just say it's an empty string, right? So that way we at least have something. We grab the X form if there's one. So in this case, it's not an error if we don't have an X form, right? It just deals with it and it says, well, it's 0. And so all of these things are basically treated as optional, except for some of the attachment properties are going to be required, right? So what it does is it says, okay, well, let's go ahead and process the attachments first. So we reach into this first node. We've done the name already. We're going to look at the attachments array, right? So we extract that as an array, get the account, loop through each attachment, right? We get the attachment object. We check it to make sure it's an object. And then we say, okay, well, let's extract the type from it, right? So we do this object property value get string. We extract type, right? Which is this guy right here. Returns this as a string. And then if we do not find it, rather, then it says unable to determine attachment type, right? And it's just going to skip it. It's not going to error or cause the load to abort. We're just going to skip it, right? And that's generally the behavior that we want from this point on. So we'll log something to the console so that the user knows that there's an issue, but we'll go ahead and try and load the scene anyway. So the next thing we'll do is we'll get an attachment type by taking the string that we were just provided, right? And attempting to convert that to the attachment type, right? And so the next thing is we'll set up a configuration for a new attachment, right? And then we'll set the type that we extracted here. And then based on that type, we will deserialize into the right type of attachment. So we have a function call for each type of attachment. These more or less all work the same way. They just extract different sets of properties, right? So I think the one I want to take a look at is going to be the directional light type, because I think that covers most of our property types. So we'll take a look at that one. And just bear in mind that most of these actually work the same, right? So what we do is we say the attachment data, we allocate some space to hold the scene node attachment directional light data, and then we deserialize that. So if I go into that, first of all, we do some sanity checking, and then we start to extract the properties, right? So we set, what we do in here is we set some defaults, right? So we default to like a white light, right? And then we go ahead and extract the color as a string, right? Because it is a string, right? It's a vector 4, but as a string. So we say get that string. If you're successful, convert it to a vector 4 and set it to attachment color, right? Otherwise, just use the default. Same thing with direction, right? Direction, we have just sort of a pointing down direction. And we say, let's take the string from that. If you are able to extract it, convert it, and so forth, right? So the next three properties are a little bit more simple because they're just floats. So in this case, we just say, hey, attempt to get the thing that's called shadow distance and store it in this float. Same thing for shadow fade distance and shadow split molt, right? These are all optional properties with defaults if they don't exist, right? And so all of these work pretty much the same, right? So point light attachment works the same way. Static mesh attachment does error if we don't provide a resource name. Terrain attachment, same thing. It errors if we don't provide the details that it needs. Skybox will error if it doesn't provide some of the details it needs, right? And so that's basically it, right? That is deserializing this file in a nutshell. And it does work mostly. There are some things that we're going to have to debug through and figure out, but it actually does work mostly. The other thing I should mention is we do have ads coming up here in a minute. So for those of you who are new here, we do pause the stream whenever ads come up on the Twitch side so that nobody misses any content. And I do see that there are some comments over here on the YouTube side. I'll get to those in just a second. So yeah, I'll probably answer those as the Twitch ads start. But yeah, there's a timer that comes up on the screen that we have so that you guys, if you need to hydrate or whatever during that, you've got a timer up there on how long the ad break will be. Over on the YouTube side, can you tell some of the niches in tech like game engine dev? What do you mean by niches? Like, game engine dev is pretty niche on its own. You have to let me know what you mean by that. All right, ads. So let's see. Okay, those are good questions that you have, Nkit. So I will, or Onkit, I hope I pronounced that right, but I will answer those actually when we come back from ads, just because those might be beneficial for both sides, right? Same, Gilherme. I hope I pronounced that correctly, but I don't feel like I did. Oh, yeah, I can actually answer that one. So what about computer graphics? I'm reading Introduction to 3D Game Programming with DirectX 11, and I struggle a lot with the API. Okay, let me actually answer that one, too, when we get done with ads. We've got about 40 seconds left on ads. That was close. The LH is a little tricky. Yeah, that's actually what tripped me up. That's exactly what tripped me up. All right, we're almost done with ads. All right, cool. Ads are dead. So one of the questions is, what about computer graphics? I'm reading Introduction to 3D Game Programming with DirectX 11, and I struggle a lot with the API. So yeah, I mean, learning any graphics programming API is going to be a challenge, right? Especially if you step into DirectX 12 or Vulkan, right? There's a lot of overhead there to understand the concepts and the API at the same time. That being said, one of the books I usually like to recommend for graphics programming also is this real-time rendering book. Let me get it close to the camera there. There we go. So this one is really good in terms of talking about how graphics engines actually render and different techniques and stuff along those lines. So that actually has a lot of information that's really, really good. And there's a whole bunch of authors on this, right? Like, I can't name them all off, but yeah. That's a really good book as well on that. What's your thought on process writing low-level code? On process writing low-level code. Do you mean like what we're doing here? Or do you mean like lower level, like OS level? Thanks for the streams. I appreciate it. Thank you for being here. Is that API agnostic? Yes, it is. I think it does mention them at times, but like it's more goes over the theory of the different stuff as opposed to the API specific stuff. Yeah. Okay. So let's see. Oh, what's the Discord? If you do exclamation Discord in the chat, it'll give you a link. So I'll just do that real quick. Good morning, everybody. How's it going, Ivo? Good to see you. This looks like very bad code when the data provided is faulty. Yeah, so this is just the first iteration of it, right? We basically have very little error checking in this stuff so far. And so the idea here is to just get it running first and then make it right. So, and that's actually kind of what we're approaching now. I never try to lock things down while I'm still trying to figure out how stuff works. I always like to get it running down the happy path first and then start dealing with actual error scenarios. Okay. Let's see. Danklink Shoe, first time chat, welcome. I'm sorry, new here. Is that Kaysen on the right? Yes. So this is the the language that we wrote, right? So this is basically what we're parsing to make a scene out of, and then this is our sort of deserialization code from the objects that are produced by the parser that reads this, right? So there's sort of a multi-step process. So kind of a high-level breakdown is it reads this file just as text first, and then we tokenize it, right? So we grab all the different various pieces of data here, like there's comments. This is an identifier. We have white space tokens. We have an equal token. We have an open bracket token, et cetera, right? So we break this all off into tokens. And then the next thing is we parse that list of tokens to create objects or properties, right? So we have the whole file as it's in and of itself is essentially a object, a root object. And then that root object has properties, right? The properties can be named. So the first property of that is named properties, right? Because it's the properties of the file or the properties of the scene, right? And that property has a value that's another object, right? And that object then has a named property called name and a named property called description with values, right? And then we have a second root property called nodes. That is an array of whatever. It could be an array of whatever. In this case, we want an array of objects, right? So we have these array of nodes, which each have properties. One of those properties is attachments, which is a array of, again, objects that define attachments, right? Attachments are things like static meshes, lights, skyboxes, things like that. And then we also have the ability to have child nodes within nodes. And then those can have attachments and or children, right? And we can optionally have a transform or not. And so what we've done is we basically wrote the tokenizer, wrote the parser, got that all up and running, built essentially an object tree out of what we get from this. And then we take that object tree and we deserialize that into our actual scene configuration, which we then pass over to a scene to load up, right? And that's kind of that last step that we're in now. Make it work, make it secure, make it fast. Exactly, yeah. So we're still in that first process of that, right? And I suspect as we move forward that this format will change slightly, and we may have to change various aspects of this as we go. So, the make it work is just sort of in the first phase of make it work. You're wondering why you didn't just use JSON instead of creating your own KSON. Valid question. So this stream is a learning exercise, right? And so we are doing a deep dive into lots of different things on here. And one of those things was, well, what would it look like if we created our own storage format and then created a tokenizer and a parser for that? And this is going to be a format that's going to be super flexible for us to use across the game engine. So we could have just written JSON, right, and used a prepackaged parser and been done with it, right? But I think that going through these steps was way more valuable in terms of exposure to yet another thing that commonly gets overlooked. YAML's way harder, yeah, and it kind of sucks, I agree. Yeah, I'm not a huge fan of YAML. I don't really like languages in general that rely on tabbing for nesting. Diamon, good afternoon, or good night. I guess it is for me, but good to see you. You tried parsing YAML in C++, it didn't go well. Yeah, that can be a little bit more tricky, actually. It's a little bit easier when you have, delimiters like this, for sure. Danklank, thank you for the tier 1 sub. And Anonymous Gifter, thank you for the gifted tier 1 sub. I appreciate that. Yeah, so that's basically what we're doing at the moment. I hope that kind of gives you a high-level idea of what we're doing. Let's see. Do you think it's possible to make a voxel game engine and a custom UI in 7 weeks with no experience from scratch using Win32, X11, and OpenGL? Probably not. I would say that would be kind of a tall order for somebody that does have experience writing all that stuff from scratch. So I would say probably not. You probably would want to, at a minimum, use some sort of framework for the platform layer, right? Thank you for the anonymous tier 1 sub. And Yak and Shears, thank you for the tier 1 sub as well. Appreciate that. Level 1 hype train complete. Appreciate that, guys. Not in 3 weeks, yeah. So, let's see, where was I going with that? So, yeah, I would use something like GLFW, for example, to achieve that. I would not do that from scratch, because just the platform layer of that will take you quite a while. Oh, no, how you think while writing code? I just kind of do. More or less. Yeah, it's one of those skills that you sort of develop. And actually, streaming has helped me with that, right? Because it's helped me think through my code as I'm sort of writing it. Because I can think out loud. And as I'm kind of walking through my thought process on something, I'll go, well, wait a minute, maybe that doesn't make sense before I actually start writing the code, or while I'm writing the code, right? That, and people always point out when I foobar something, which is great because it's like a free built-in code review. So there's a few advantages there for sure. Look into that. Thank you. Yeah, perfect. Singy, hello. How's it going? Good to see you. Math library is a fun experience. Yeah. For math, just use GLM. Yeah, if I was doing this outside of like Kohi, where I had to, sort of build something for production, right? That wasn't just a learning exercise. I probably would have done that too. I probably would have used GLM. But since this is a learning exercise, we built ours from scratch too. I think at this point I have about 70% parity with GLM, but I wrote it from scratch myself. Yeah, exactly. You don't need many of the GLM functions. I find the same thing. It includes like a lot of stuff that you just don't need, right? I agree. Hamster Dev, how's it going? Good to see you. All right, I think I finally caught up on chat. Okay. So with all of that said, I'm just going to do a clean real quick and a build. And I'll show you guys where we're at. Capuche Man, first time chat. Hello, welcome. Unneeded stuff just adds to the compile time. Exactly. That's why we don't like unneeded stuff around here, for sure. What about DirectX math? What about it? Now stop reading silly chat, get coding. Well, I have to read some chat, Dreading my TypeScript work tomorrow. Feels bad, man. Yeah, I hear you on that. Loud and clear. All right, so let's take a look at all right, so we load, and we're kind of working. All right, we load the Sponza, we load the car scene, but there's some things that are foobar about this, right? You'll notice that the lighting is just wrong. And then the other thing you'll notice is that like our tail light that we added to the car is just not there. So there's that, and then the tree object is here, when really it should be like outside the building over here near where the car is, right? So I suspect we have some issues with the way that hierarchy is working. And so we'll have to kind of look at that, as well as we'll have to look into why the directional light isn't working and why the point light isn't working, right? But some of the basics we have, like our terrain loads in. Our terrain loads in fine. Our static meshes load in fine. But there's some other stuff around that we need to really figure out. The other thing is it crashes on shutdown. So we'll have to get to the bottom of that as well. It's a Vulkan validation error, which is interesting, upon freeing descriptor sets. So I don't know what the heck's going on there. Skybox unload. So I'm wondering if this is sort of fallout from one of the things that oh, okay. So right away we found an issue. Why do we have two skyboxes? There's only one defined in the data. So let me see. Where's the tree? Yeah, exactly. So yeah, there's a few things that are going on. It looks like our child nodes and our lighting isn't acting correctly. An editor would be nice now to see what's wrong. Yeah, exactly. We're getting to the point where we're going to need an editor here soon. And I'm actually kind of glad that we have the gizmo already figured out, because once we have scene saving, that's going to be important for sure. So we're getting to that point, right? Where we're going to need an editor before too much longer. For right now, we're probably going to be able to just hand edit files, but okay. So Big Chungus Forever. Thank you for the follow. That's an awesome username, by the way. All right. So why are we getting two skyboxes? Let's have a look at. Let's have a look at. I wonder if this is actually even deserialization at all, because we did have some temporary code where we kind of hard-coded this stuff. And so I'm wondering if that is actually coming back to bite us. So this is, let's see, this is deserialize. So this is where that hard-coded stuff lived before. But before I do that, I think that's where all of it is. Let me just make sure the loader didn't actually have anything left in it. I don't think so. Scene loader writes. Okay, so we're not there yet, right? This is another to-do that we have to do. Where we basically have to serialize the scene so that the loader can understand it. Okay. And I'm not 100% sure, FYI, about the interface for this, if that's how we want to handle this or not. We may not actually do this through the loader. We'll have to see. Oh, we got a raid. I'm not Gam. Thank you for the raid of 2. I appreciate that. Welcome. What did you get up to on stream? Let's see. Hello, Perry Let's, and I'm not Gam. Hello. Welcome. Is there like a hard-coded skybox in the one from the file? That's what I'm wondering. That's what I'm looking into now. Yeah. Hi, I'm new to your stream. I just discovered that we can run C program with VS Code without using GCC. Yes, you can. Yeah, you need some sort of compiler for sure, right? And technically that hooks into GDB, or on Windows it uses the Microsoft one, right? At least that's more or less what we're doing in this case. You're working on a multiplayer game. Like 2 years ago, you made the mistake to try and make a multiplayer game. It's fun. Yeah, that speaks to experience, where you're like, you made the mistake of making a multiplayer game. That's experience talking right there. I totally know where you're coming from on that one. Are you using like a game engine to do it, or are you rolling the tech on your own, or how are you approaching it? Making it's fun, but playing against the box is absolutely kicking my butt. Yeah, you're using Godot. Okay. Godot seems pretty good. I need to try it one of these days. I haven't actually tried it in, well, quite a while, honestly. I played around with it when it was like in its infancy, but I know it's grown a lot since then. Godot and piggybacking off of Steam servers. That makes sense. That's probably a pretty reliable thing to do. Godot is nice and it gets better. Yeah, I've heard a lot of good things about it. I just haven't had a chance to use it anytime soon, recently, just because I've been rolling my own, right? All right. So we did have a hard-coded skybox in here at one point. But I think all of that code has been killed, right? Because this is all commented out. The only reason I kept this stuff is so you know what? I don't even need. I'm going to actually get rid of all this. I don't need all this stuff anymore. This was our sort of hard-coded copy. We'll get rid of it. We're just going to rely on the deserialization for now. Okay, so how are we winding up with... two skyboxes? So, let's see. When we load the attachments, let's see, we'll go into deserializing the node. And for reference, by the way, for those of you who are new, we have, this is essentially our storage format for our scene files. It's a little bit more generic than that. It's loosely based on JSON, but it's our own format. We wrote a tokenizer and a parser for it from scratch, and now we're handling the serialization, deserialization, to and from this format to actually load up a scene. So, wanted to do my own engine. I was using the Kohi videos. Then I saw the tutorials stopped and gave up for now because I have stuff I want to do before. Yeah, fair enough. Fair enough. It kind of evolved past the point where tutorials made sense, right? Tutorials make sense when you're bootstrapping the project, but after a certain point, like, you can't really tutorialize that any further. And that's the reason that most engine tutorials never go that far, right? And I'd like to think I took mine pretty far, but you still, at a certain point, it's like it doesn't really make sense anymore. The tutorials basically become these huge, long videos anyways, and it's like, well, we might as well live stream it, and that way you guys can see the development process as well. You saw a video from Tej yesterday writing a LSP from scratch in Go, and you're tempted to write one from KSON as a learning experience / joke. I have been tempted to write one as well, utilizing the tokenizer parser that we have here. I've been very tempted to write one, actually. Just so that we get like syntax highlighting and maybe code completion at some point. But I didn't want to start that until like we lock down the format, because there's a couple things that I'm thinking we might want to change. You still have tutorials basically, they just run for 2+ hours, yeah. There's I think we actually hit 5 hours on one, but that's like exceedingly rare. You did take it far. It's something like 50 videos, right? I think it's further than 50 videos. I'm trying to remember where I switched away from the tutorial format. It might have been around like 106 or something like that. Yeah, the tutorial format went on for quite a while. I don't remember exactly where it cut over, to be completely honest. I think it was around the 100 video mark. Okay. So when we're deserializing a node, we get the name, we get the XForm if there's one. Here's the attachment processing. So we get the attachment object, make sure it's an array, get the element count from the attachments array, start at index 0, as long as that is less than count, and then we increment that index. We get the object at that index. So in this case, it is the array, the index, and then the attachment object that we're extracting, which is right here. So that seems fine. We double check and make sure it is a object, and then we extract the attachment type from that. So let's see. This first one is a skybox, right? So this is the first type of attachment that we're going to hit. So we come down here, and we do skybox, which is right here. We do have a break statement there, so we're not falling through. New attachment data is of type node attachment skybox. Deserialize scene skybox attachment. We checked that to make sure it was successful, blah, 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 blah. So let's, I guess, have a quick look at that. So we're not getting any failure messages in the console, for one thing. All we do is extract the cube map name and return. So I don't think that's the problem. So we break here, which would bring us down to here, right? If we don't have attachments, we create the attachments array, then we go ahead and push. I wonder if the push is potentially screwing it up. So let's have a look at, actually, let's see, 285. Let's put a breakpoint. $285. Right, let's actually put a breakpoint here. And we'll start taking a look and see what's going on. More text. Thank you for the follow. Appreciate that. Wait, is it resizing after the first push, but the length should still be 1? I think, well, okay, so this is going to resize. It's definitely going to resize because we have this skybox attachment, and then we immediately after that have a directional light attachment, right? So when we create the D array, it should have space for 1, which we then immediately push. And then we'll come through a second time and we'll create this one and then push that, which does or will create a reallocation on push. And I just want to make sure that it's not doing something funky here, right? So new attachment gets pushed there, and then I believe that is the end of the loop. Yes, so it goes on to the next attachment index. So let's load this up. The length should still be 1. Well, it wouldn't be 1 after that, right? Because we're not actually here. So just do a sanity check on this, right? So we have attachment count is 2. We have the attachment index. We're starting at 0, right? We have the attachment object, right? Which is its first property is type string, type skybox, right? If we look at the new attachment, it is a skybox with data. So when we push this, right, the header length is 0, right? And we should have a capacity of 1. We do, right? So we don't need a resize for that one. We can simply copy into that memory. Let's see, do I have... Let me actually... come on. Why do they make the resize grab zone so small? Okay. Let's nuke all of these. And we'll do array. And we're going to cast that to actually, before I do that, we want to step out of this function because that's not going to work otherwise. Right, so we want this, actually. Right, and the size for that we're going to use is 2. So if we expand this, we do have... What? Okay. I wonder if that's just garbage memory and it's just picking that up for some reason. Yeah. It's got the same attachment data address too. Okay. That's a little bit strange. I wonder if that's just a... Oh, I think I see the problem. I do see the problem, actually. Fortunately, that problem's going to have to wait until ads are done. Let's see. Is it a node-based format, i.e. arbitrary deep nesting possible? Yes. That was one of the reasons that we refactored it, was to get however deep nesting we want configurable within the file. So yes, to answer your question. After these messages, exactly. FV7, hello. How's it going? Good to see you. Welcome. Oh, thank you for the hydrate redeem. Appreciate that. Almost done with ads. Got about 20 seconds left to go, and then we'll get back to it. They should have an ergonomic one for programming channels. Do you mean like a posture check or something? Right, and we are done with ads. Cool. All right, so actually, as I was stepping through this, I saw the issue. So we're going to look at line 280 here. So if we take a look at attachments, we are DRA creating that, right? Scene attachment. But if we take a look at attachments itself, we have scene node attachment config is the actual type. So chances are we were probably not generating enough memory to actually handle this correctly. And I think that's the problem. And what's really gross is the compiler didn't pick that up. So I'm going to have to see if I can figure out a way to not do that. Right? Maybe we set up our DRA macro to return the type or something so it bleats about it. Right? Because I think right now it just returns a void pointer, which is not great. We'll see. Okay, so writing tests would not have actually solved this, right? Because in the test, why would I feed it like a different type, right? You wouldn't necessarily write a test for that. And so what basically happens here is it does a type of, or a size of on the type that you pass here, and it uses that for the element length, right? But then this DRA create returns a void pointer. So that never would have been caught by this type difference because C just allows that. In the test, you could have tested for the type, right? So I'm going to see if I can modify this macro to essentially return the actual type instead of void. I don't know. The only problem with that is like all the other functions also take void pointers because they don't know the type ahead of time. So that might get a little bit messy. I'm not going to do that right now, right? But yeah, that's one of the bad things about using void pointers. That is the issue with void pointer types in C. Yep, unfortunately. C++ actually requires you to cast it. In order to assign like this, but yeah, C, not so much. So it is a little bit better that it's a little bit more strict in that regard, but Agent Orange Ogre, I love the name. Thank you for the follow, I appreciate it. Welcome. But those functions should accept any pointer, and it should autocast to void when you call a function. And that's, I suppose, the way that I could do it, right? Let me get rid of this because I don't I don't think that's the issue. In fact, let's see. So we have... Oh, that's going to do it on every single one. Don't need that. Okay, so we have this. Load up the scene. So right now, what we have in here is attachment type unknown. Now, it's only zeroed the memory for this first one, right? Because that's all the memory it has allocated for it. So what's down here is rubbish. That makes sense because we haven't actually allocated this block of memory yet, right? So if I do a deray push here, notice now it only changes the first one. I think that was the entire problem, is we just had the wrong type there. And so what I'm actually going to do is I'm going to disable this breakpoint, and I'm just going to continue and see what we get. Hey, look at that. Fixed it. We have, well, it partially fixed it. So we have our light information back. We have our shadow maps working. Our directional light works. Our point light works, but is in the wrong location. So that's interesting. I could have swore that I modified that last time. And I think the tree is actually still in the wrong location. Yes, the tree is in here, which is not right. So I'm wondering if that didn't get parented properly. The tree is in the wrong position too. So the auto mod counted your abbreviation of position as foul language. That's hilarious. Because it thought you were saying POS. That's funny. And the roof looks weird. So the roof is actually an issue with the mesh itself. You're talking about this. You're talking about these. So if we swap to the normal data, you'll notice that those are black. That's because the normals on this mesh are kind of screwed up. They're not valid, right? So that's the reason that those show up kind of weird. If we switch to lighting mode, it's the same thing, right? Because it's not valid normals. But otherwise, this looks correct. We can actually see the red tinge here from that light, right? So we know the light is working. It's just in the wrong position. And the tree itself is also in the wrong position. So we'll have to figure out why that is. Notice we also don't get that shutdown error anymore. And I suspect that's because of the dual skybox issue. So it's interesting fallout from that. Wrong normals. Yeah, most likely there's probably nans in there somewhere if I had to guess. You know, not a number. So it could have, I think the original mesh actually had some issues. So at some point I'm going to replace it with a better one. Okay. So the next question becomes, what do we do in the case of the children? I see the problem already. I did the same thing again. Womp womp. All right. So that was line 313. It's going to be hilarious if that was the entire issue. So the children array is a scene node config, not a scene attachment. Oops. Scene node config. I'll bet that fixes that issue too. Yeah, I tried to free the Vulkan stuff twice before. Yep, exactly. Which I suppose, I'm not sure if I should even bother guarding against that, right? Would it be valid to pass the variable and do size of type of var? Good question. I don't. Well, theoretically, I only need... Theoretically, I only really need the type once, and that's to get... Or the size once. Really, I only need the type of once as well when I'm initially creating it, right? Because the only reason I need that type, initially at least, is so that I know how big each element needs to be. Before I move on to that, let me test this and make sure this fix works, and then I'll jump back into that because maybe we can find a way to make it a little bit more robust. It is going to be interesting to see what else it breaks though. Okay, so the tree is still not in the right position. Did I rebuild? I don't know that I did. All right, so scene node config. Okay, this is saying I rebuilt, so this might not actually be the same issue. I don't think it's the same issue. There's something else going on here, for sure. Okay. The other question is, yeah, see the light is still here. And realistically, the light, I think I had placed it at the back of the car before. So the position still worked. For the stride, exactly. Yep. When you create it to ensure you don't mistype it. Yeah, exactly. So like, and I'm wondering how many places in the engine it's actually going to throw that issue because I haven't actually. Right. So this is the macro right here, right? And DArray create is essentially what it calls, right? So it just kind of passes the type through, saying, give me the default capacity, and then the size of this is the size of our element size, and then we just pass it through to this. So, the problem with that is we'd essentially have to get that to work to return the actual correct type, we would have to do away with this actual function and have it defined every time we call this, right? Which I'm not sure that I'm willing to actually do. Because that's going to make it a nightmare to debug if I do that. Trying to think if there's a way around that. You don't have to typecast the output of the DArray create, right? I'm not typecasting the output of it right now. But I'm thinking that's how I would have to get around it, right? Sounds like metaprogramming in C++. Yeah, exactly. Because I don't think I can do. I don't think I can do. I don't think I can do that. I don't think that's valid. Or maybe it is. Maybe that's it. Maybe that's all I need to do. Because it expands the right thing. So maybe that would catch it, right? Like if I did U32 here. Aha. It bleats about it now. Look at that. And I don't even need a template. I could literally just cast it right there, right then and there in line and get an instant warning about it. Who needs C++? Exactly. Yeah, just a raw cast. And then I don't have the overhead of having a copy of all the code for each type that I use. That's the whole reason I don't use templates in C++, because that sucks. Raw dogging. Yep, exactly. That's exactly what we're doing. So that is actually... Okay, so here's my question. How many places in code is this going to break? Do I have warnings turned on is the next question. Or warnings as errors. I thought I did. I mean... Was it really that simple the whole time to just do that? Because now I actually get proper type checking on that. I still don't think that's going to solve the problem, because I don't think that was a problem, but it wasn't the underlying problem, right? Yeah, that transform's still foobar, right? And this one as well. So it's not... Child objects are not being transformed correctly. So I think what I'm going to do here is I'm going to go into the actual scene itself. And let's see. Let's look at our queries. Right, so we're going to do our render data query, or mesh render data query. That's the one we're going to want to look at specifically. Right, and let's get the handle for that. So let's see. We have the mesh. So that's the Sponza mesh. We don't want that one. Here's the tree. Okay. So if we take a look at the xform handle, that is index 2, which if I recall correctly is the right one. We want xform world get. So in here, we have a valid handle. World matrices, the handle index I think was 2 on this, so let's take a look at what that is. Okay, so it does look like it's been transformed. At least it's, let's see, that's its world transform, right? So did we set this up correctly? Okay, so if we take a look at the transform for tree versus the transform for its parent Sponza, right? The Sponza is almost at the origin, right? And then its scale is very, very small, right? So it's basically going to take everything of this minus the rotation, right? It's going to take the position and the scale and divide it by 100. And then that should give us our final transformed coordinate, right? So if we look at the tree's position here, and then we look at the position here, we have 700 divided by 100. Okay, that looks correct. We have 80. Let's see, that's going to be multiplied by... Okay, so we'll get 70... Wait a minute. 140. Yeah, we have some rounding errors in here for sure. But I think these are actually correct. So I think position looks good. And the scale is 2.2. Which does make sense, right? It's 2.2 all the way across. So these guys right here. Okay. So the world matrix is correct. So did I just miscalculate? Like, did I not update these and thought I did? Or did I not update the file with like the new values that we had hard-coded? Maybe that's the problem. So let me split this one off to the right. Let's see, split right, there we go. And over here, let me look at the scene loader, at the code that we deleted, because this was our hard-coded stuff that we had in here. So our tree. So our tree is, wait a minute, where'd it go? Here's our tree. So our tree wound up having a scale of, oh yeah, the numbers are wrong, actually. Wow, VS Code, why are you like moving around? Okay, fine. Copy deleted lines. I'll put this into a different file since you're being a dingus. Okay. So if we take a look at our, that's the terrain. Tree. Okay. So the tree had a transform scale of 200. So I must have forgotten to update the actual file. That's what it looks like. All right, so let's stop this. This should be 200. I must have updated the hard-coded version and forgot to translate it over to the file. So 780 and then 1400. Okay. So we have that identity rotation. Okay, so that looks correct to me. The other thing, let's see, what else was it? It was the red light was the other thing I was messing around with. And I think I just literally did not update the file for that too, I'm guessing. So here's the red light. So let's find that here. Actually, let's just do this here. So the red light is here. Right, so the color was fine. I think it was just the position that we actually changed. So it's going to be that, yeah, the position's wrong too. Yup. So let's take this, put it here. Boy, copy pasta's hitting me hardcore tonight. All right, so let's load this up. We did find a legitimate bug in the code, but there we go. And our light object is where it should be, all right? Attached to the back of the car. So that means that we can come in here and select the tree, move him out of the way, select the car, and move him around, and the light follows, right? Now, I should mention that the light is not reflecting off the wall here because the normals there are foobar. So let's move the car inside the sponsa and look from that perspective, right? Let's just see how it looks inside, right? So we'll go ahead and move this, right? And we can see that that light is definitely following the car now, right? Cool. All right. That's done then. Deserialization is done. All right, so let me catch up with some chats here. Thank you guys for the follows, by the way. Appreciate those. Dingus party parrot. Yeah. Yeah, definitely dingus mistakes tonight for sure. Let's see. Okay. Bad root transform for the child. Nope, it was just my mistake in the actual in the source file, right? In the actual scene file. So I had forgotten to update a couple positions in here. Some of the transforms are wrong. Let's see. Question, what is the downside of doing define darray create var, darray create default capacity, size of type of var? Is it just no warning? So you're suggesting doing this and then just passing the actual variable here. Is that what you're saying? Fadson, first time chat. Finally found some time to watch your stream. Well, awesome. Welcome. Glad to have you here. Is there a video where you showcase your plugin system? I saw in one of your reels, and it sounds super neat. So we don't have a standardized plugin system yet. All of our plugins sort of work through their own individual interfaces because there's very specific interface points for that. But I can show how those plugins work in just a minute. It's just, kind of like a renderer plugin works very differently from an audio plugin, right? And so we'll take a look at that here in just a minute. Praise be. Yeah, exactly. Getting off topic a little, what do you think of the technologies like DLSS and ray tracing? I mean, it's awesome stuff. It makes it look better, right? We're eventually going to touch on hardware accelerated ray tracing on here at some point. But that's way down the line, right? We have much more other important things to do. What's your GitHub? So the Kohi project is actually under my GitHub. So I'll drop a link in chat for that so that you've got that. Oh, Iva, looks like you tried to post a link. Yeah, the bot doesn't like when you post links. You just posted the GitHub. Yeah, I appreciate it. You know what? Actually, Ivo, you've been around long enough. Let me see if I can get this. I trust you. I'm going to give you VIP. That way you can post links. Cool. All right. So let me see. I just have to catch up with the chat here. Yes, I'm in South Carolina. Yep. Why does your mod delete all my posts when he mutes me? That's just kind of the way the silence goes, is it just nukes them all for some reason. I don't know why it does that. But yeah, if you should be able to post links from now on. I trust you not to post anything nefarious. You posted the link. Why was I auto-modded? So if you write anything in chat that is like some string dot 3 letters, it thinks that's a link. So basically just don't do that. Space it out, type DOT instead of dot, that kind of thing. One of us, exactly. Yeah, no problem. Like I said, you've been around a while. We've had lots of chats and stuff, so I trust you. Send them all to my OnlyFans. Yeah. My OnlyFans is, it's going to be lots of nefarious pictures of letters and numbers. That's about it. All right. Beard grooming. Oh yeah, there you go. I'll start an OnlyFans that's just me, like, combing my beard. Dog pictures and cat pictures. Yep. Lots of dirty compound macros. 100%. That's awesome. I love it. I wonder how much traction something stupid like that would get. I don't think I have the following for it to really take off, but that would be super funny. We have ads. So for those of you who are new to the stream and or can hear me over on the YouTube side, we get served ads once every 30 minutes on the Twitch side for up to 90 seconds. So I like to just pause the stream so that nobody misses any content. And I usually encourage folks to hydrate during that break because hydration is important for your health, right? So do that. Let's see. So we got about a little over 45 seconds left. So Roman General over on the YouTube side, you say, as a C++ developer, it's hard for me to follow the code. However, I try to watch as much of your vids as I can. Well, I appreciate that. What about it is hard to follow? Is it just like the use of raw pointers and stuff? Because if you wrap your head around that stuff, C++ makes a whole lot more sense when you actually go to use it. C++ tries to abstract that stuff away from you these days, which I think is a bad thing, personally. But that's my opinion, right? All right, ads are done. Okay. Not to forget, lots of birds with arms vids. C is just C++ without classes and no standard library. Yeah, exactly. No templates either, but who needs those? Do you have another job beyond your work here? Yes. I'm a full stack developer by day. So yeah, this is my passion project. I have done game dev in the past professionally, but I don't anymore. I got tired of working 70-hour weeks. So now I'm a full stack dev. Templates, worst part of C++. I would agree. Also, operator overloads are the most bastardized thing out there, for sure. Like, the overuse of these operators for streams, absolute rubbish. Whoever thought that was a good idea? And by night he transforms, exactly. It's incredible how you basically only need to include stdlib h and you have all C at your disposal, more or less. Yeah, there's a string.h is needed for malloc, right? But that's about it. But yeah, in C, if we don't have something, we just write it. It's not that hard. The UFO operator, yeah. It's new since C++ 23. C++ has just... It's a massive disappointment, I think, the way that it's gone. There are some good things every once in a while, but it's such a bloated language that just has more and more and more and more crap tacked onto it. It's huge, it's clunky, it's slow, especially in terms of compilation speed. Like, what a joke. Yeah, it's I stopped using C++ at C++ 11. That was the most recent C++ that I used, and I never went beyond that. The debate between C and C++ can go on forever. Both have their pros and cons. I prefer C++. Yeah, I mean, there are some good aspects about C++ that I do miss in C. Constant expressions are one, right? That's a huge one. That's probably the biggest one that I miss. The only other thing that I miss from C++ is maybe operator overloads specifically for math types, right? Multiplying and dividing and adding vectors and stuff like that. But otherwise, I don't use OOP. I don't have any use for classes or all that inheritance. Can have it. I don't use it, right? C++ gets more and more lazy. Yeah, I agree with that for sure. And it just tries to take, like, it tries to manage your memory for you now. And my problem with that is, like, if I wanted to use a language that would manage my memory for me, I'd use a language that would just designed to do that. Like, if I'm using C++ or C, it's because I want to manage my own memory. Stop trying to manage my memory for me, right? How memory safe is my engine? I mean, right now, since it's still in progress, not much at all. But, you know, when we get ready to, like, we're gonna do several passes probably on this to batten the hatches, right? But I don't really bother too much with that as I'm developing, right? I try to clean up stuff where I know it needs to be cleaned up, right? But, like, we write our own allocator, so I can track all that stuff. I don't just allocate willy-nilly from the OS. I get one big arena of memory and then dole that out. And so that allows me also to track if I have memory leaks very easily. Okay, cool. So, not huge on RAII or constructors, destructors either, since you lose a lot of the nice guarantees of C-structs. Yep. The one place that I have found that automatic destructor would be nice would be, like, if you had a logging, like a logging or performance counter within a certain scope. Then it would be nice to not have to say, you know, timer begin, timer end at the end of something if you're trying to test, like, a critical section of code. But that's, like, the only time that I would actually want that. Otherwise, I'd much prefer to be explicit about it. Yeah. If I stopped at C++ 11, a lot's changed since then. Exactly. Even then, I avoid those versions of C++. You don't go below 17 if you can get away with it. Those are called the dark days of the language. So I know one of the reasons I didn't step outside of that back in the day is because a lot of platforms actually didn't support it, right? So consoles, for example, just wasn't available, right? And you don't use a lot of that stuff on consoles anyways. So, you know, if you're building only for desktop, that's fine. But when you're building consoles, it's a whole other ballgame, right? Other than that, love your engine, love the passion. Awesome. I appreciate it. You know, like I said, it's preference, right? I don't like to use OOP. Doesn't mean that I'm saying you should never use OOP. I just don't like to use it, right? It's preference. Plus, there's a lot of series out there on, like, how to write an engine in C++. There's not really for C. All right. So now that we have this done, we can start thinking about what it would mean for us to save a project, right, or a level. And this is where it gets a little bit tricky, only because, you know, there's a couple of ways that we could track this. Oh, I saved that var change. Whoopsie. Let me just undo that real quick. I was like, why are my D arrays broken? Okay, that's better. Did you see the mini dev documentary on Crash Bandicoot for PSX? Yes. It's fascinating. Because back then there wasn't any triangle sorting, right? They were essentially sorted by the order that you drew them in. And so all of the polygons that were drawn on screen were drawn per frame, and they had to basically cull triangles manually. What console program am I using? You mean like this editor here? This is NeoVim. Yeah, it is insane. I was actually thinking about doing, like, a small project like that just for fun. making like a software renderer that worked that way. It'd be super fun and nostalgic to go back to like the PS1 era of games, right? I was thinking that might be a fun project to tackle at some point. Maybe I'd write it in a different language like Zig or something like that. You have the tabs at the bottom. What are those from? Tmux. So I used to use Tmux, but I recently switched to WesTerm, which is the terminal that I'm using. And it actually has a multiplexer built in. So this is actually part of that terminal as well. It's pretty sweet. So yeah, WesTerm is what it's called. I'll actually, you know what? I'll do one better. I will pull up. So it's not sponsored or anything, but yeah, this is the terminal I use. It's cross-platform. It's fast. It's easy to configure, and I like it a lot. So it's a pretty sweet terminal, even if it is written in Rust. That's right. I was going to show the plugins. Okay, so I got. I guess the best way to do this will be to explain it a little bit architecturally first, and then we'll go from there. So, in terms of, I don't remember who it was that was originally asking me about this, but in terms of the plugin system, that sort of requires me to go over the architecture of the engine as a whole. So, basically, what we have is our file structure here for right now. Includes the engine, which is a shared object / DLL, right, if you're on Windows. And so that contains core things like our containers, our memory management, our graphs, our math, our parsers, platform layers, like our Linux, Mac, and Windows platforms layers. And it also includes a renderer, what we call a renderer front end, right? And the renderer front end is the API agnostic part of the renderer that communicates with the rest of the engine, right? So the rest of the engine is not concerned whether we're rendering using Vulkan, OpenGL, Direct 3D, or Metal, or whatever, right? It does not care. In theory, we could actually have a headless renderer running as well, which means we have no window, we're not drawing anything, right? Maybe we'd use that for unit tests. Or maybe we'd use that for running a game server that maybe needed to have physics simulation but not actually render anything, for example. Anyway, and so we have that, and then we also have various other systems, another one of which is the audio system, which also is a front end. And so those have a back-end component, which is a plugin. And so our Vulkan renderer, for example, is a plugin. And it plugs into the engine and is loaded by the application. So what does that mean? We have an application here that what you guys see me bring up on the screen is called our testbed. And that's our actual executable. That's our application. It's very light. It contains one file. That is the entry point. That basically is a set of configuration on how things are loaded. It tells the engine what all of our function pointers are to hook into the game, as well as any plugins that we need loaded, right? So it provides all of those. And right here, we can see right here, we have two plugins. We have one plugin that's being run for Vulkan that's being loaded. And then we also have a plugin create within that actually stands that up. And then we have the audio plugin here that's stood up, right? And so the application has full control over what plugins it uses and can configure those plugins, right? Initially, right now, those plugins are loaded by the application. Eventually, this is going to be shifted to configuration that the application actually uses or provides, and then the engine will actually be responsible for this. But for right now, the application does it. The entire application code is 196 lines, right? The application is extremely light. And so what that benefits us is we have the ability to separate out our application code, which here is we're calling testbed lib. So testbed lib is where all the actual game logic or application logic lives. And the advantage of this is that it is hot reloadable code, which means within reason, we can edit certain things in the code, compile it while the engine is actually running, and it will automatically reload that new version of the code. And so separating these out affords us that ability. So the Vulkan renderer is where all the Vulkan specific code lives, right? So the Vulkan backend is what is sort of the main version of that, and then we have a few split out pieces that split out various pieces of Vulkan functionality into different files. But the main meat and potatoes is in this Vulkan backend, and I think this is around 4,000 lines. Yeah, 3,900, right? And then, so that's our Vulkan renderer, and then we also have the plugin audio for OpenAL. So right now we're using OpenAL as our audio backend. And what that basically means is that we are using OpenAL to provide the audio for us, right? And we could use direct sound if we wanted to. We could hook this into like SDL if we wanted to do that. We could implement all the different platforms, audio libraries separately if we want to do that. But OpenAL kind of does that for us, right? We get that out of the box. So I'm using OpenAL to give us basic sound for right now. That also affords us to have 3D spatial sound, which we do actually support. So that is that. If we wanted to use another library, we would simply create another plugin and use that instead. So the application can decide what it wants to use for that plugin. And again, we could have a headless one, which essentially would be a no-op for any audio operation. So if you were trying to unit test things in the engine to kick off audio playing or something like that, we could certainly do that. So that's that. And then also the UI system itself exists as a plugin, right? Because the UI system is what we're calling our standard UI, which includes your typical buttons, your text boxes, your radio buttons, your scrolling containers. We don't have all of that stuff implemented yet, but we're building it from scratch, right? It also contains our drop-down debug console. So for an application like an editor, right, which would be another example of an application that would consume the engine, you might need all those controls, but maybe for your end game, you don't need those controls. And so the application can say, you know what, for my game, I don't want to use the standard UI. I just want to, have just a couple of basic bitmap things that I can click, right? And I'm just going to implement my own system for that. But for the editor, I do want to use that system. And the other thing you can do is you can mix and match based on various builds. So you could say, well, for my debug build, I do want to use the standard UI because I want to have that debug console that drops down from the top of the screen. But on release builds, I don't want that. So on release builds, I'm not going to include the plugin, right? So you have that kind of flexibility as well. And so that's why we're sort of going with a plugin-based architecture. So when I first started developing the engine, it was not built with that in mind. I was just going to kind of have everything under this monolith engine, and we were going to just sort of do it that way. But as I got thinking about it, I'm like, we should probably split this stuff out. That way it's easier to just sort of plug in new things as we have them. So I hope that makes sense. Grim Heartless, good to see you. Glad you have an active audience so quickly. Take it easy. All right, I appreciate that. Thank you. Let's see. Compute only renderer. Yeah. So compute is something we have that's on our to-do list as well, actually. Fadson, how's it going? Zig is nice, phenomenal, actually. Yeah, I've heard a lot of good things about it. I'm going to try it and Odin, actually. I haven't decided what projects I'm going to make in it yet, but I am going to try those things out. Let's see. This should actually just be a single call to engine init with a struct. Yes, that's so eventually all of this, all of this stuff is going to be offloaded to the engine. I put it here just because it was very easy to stand up, but all of this stuff is going to be offloaded to that, right? It just made sense when I was kind of building it out initially to put it here. But yeah, actually, it's not even really going to be here. Actually, all we're going to wind up with is a KSON file. I'm going to leverage that actually to configure this stuff. We're just not there yet. User having to write all that code is bad. Yes, I agree. But, I mean, it's only 196 lines, right? Compared to Vulkan, that's nothing. No, I'm kidding. Like I said, a lot of this stuff is going to be moved out of here. So this is the entire application, right? At least the executable, right? It's not that big, but we definitely don't want the user writing this stuff. So we are going to have this be configurable so that the user doesn't actually have to do all this stuff, right? And what we're going to do is we're going to have the plugins themselves actually provide a list of what these function pointers are. So the plugins themselves will provide a default configuration that the application can then override. And that way when the plugin is loaded, you don't have to do all this crap up here and all this stuff with the function pointers and stuff like that, right? All of this, right? So that's the goal, anyway. Great breakdown, thanks a lot. Same, no clue on a project. Yeah, fair enough. Yeah, I'm glad that made sense. Thank you for the detailed explanation. Yeah, no problem. So, yeah, compared to Vulkan, it's nothing. Yeah, now back to saving scenes, 100%. So, yeah, we are definitely going to be simplifying this. It's just there's other things that have taken priority. Okay, so saving scenes. My initial thought behind this was we'd have this scene loader write, which would take in a resource loader and a resource, right? But the part that kind of sucks about this is that we actually have to create this resource, which doesn't always necessarily make this the most sense, right? And also, having something that's a loader also write is a little bit weird to me. So we're going to do away with this. And instead of actually handling it this way, we're going to essentially get the base file path for the type of resource, and then we're going to perform some serialization, which actually right now is still in the scene loader, which is also wrong. Right, we need to move that as well. And then in the serializer, we can then, I'm thinking, add a function. Well, actually, the serializer itself would essentially call a parser to convert the whole thing to a string. Then once we have the string, we can then literally call the file system from anywhere and just write to it, right? So I don't think we need like all this loader write stuff. In fact, let's see. I think, yeah, we did do something for that. So we actually had put this into our interface, and this is not great, right? So I'm actually going to undo this. And even when I was writing this, I wasn't sure about it. Not a fan. So we'll get rid of that. We'll get rid of this. I feel like that might actually break the systems manager. Yeah. Scene loader. Okay, it makes sense that doesn't work there. And actually, you know what? I'm just gonna, let's do this. I'm gonna take this. Do we have a save? Save. We do. Okay. So I'm going to put this right there. To do serialize and send off to parser to create string, then write to file. right? And for right now, I'm going to leave that commented. All right. Scene loader. Okay, so we can actually get rid of scene loader right. We don't need this. All right, so let's remove that. And then I think we did not do it in here. Okay, perfect. Okay. We also have this to do. I do need to handle that, but I feel like that probably I don't need to do on camera, right? I could probably just do that off camera and show you guys that when it's done. I do need to destroy the nodes, right, when we destroy the resource, because we are leaking memory there, which is why I put a to-do there, but I feel like I should just do that off camera. So let's go back to the scene. And let's actually go, let's kill this window. And let's see, scene save. So in order to save the scene, we're going to need a lot of the information that we initially had when we created it, which we're not hanging on to all of that, I don't think. Let's see, I want create. So we have the config. Do we save the config? I don't remember if we do. I don't think we do. Oh, we do. Okay. So there's going to be a lot of things that we're going to do that are going to deviate from that config. So I'm trying to think about, so for example, when we load up a mesh, we don't keep the name of that resource that we loaded for that. Same with the terrain. Same with the skybox, actually. We could probably get it if we wanted to, but we don't actually hold on to that information. We sort of go through here, loop through, create our hierarchy, etc. And then we just kind of forget that information exists. I guess we are saving a copy of the config, but if we start changing properties and we start changing the hierarchy of things, that configuration is going to be wrong, right? So we don't necessarily, I should probably look into not saving that config, right? Because we actually are doing that here. So to do, don't save off config beyond. Oh, I know why we save it off. So when we create the scene, we haven't actually initialized anything, right? We create the debug grid, and that's the only thing we do. We haven't loaded any assets, we haven't loaded anything. Then we need to initialize, which is what creates all of our scene hierarchy, right? And sets all those things up. And then we actually load. And then once the scene is loaded, at that point, we could probably kill off the config. So I'm just going to put that in here. Destroy the config once loading is complete. Right? So we should probably throw away the config at that point. What that also means is we should also take into account the differences between a scene loaded into the editor versus a scene loaded in runtime, right? Because those are going to be vastly different things. Oh, Reset, thank you for the follow. Oh, thank you for the posture check, by the way. Appreciate that. We have ads. So for those of you who are new to the stream, we pause the stream once every 30 minutes for 90 seconds or up to 90 seconds because that is how often we are served ads on Twitch. So I know on the YouTube side it's not quite the same thing, but on the Twitch side, that is basically how we roll. So I like to pause the stream so that nobody misses content. Also gives me a chance to hydrate, gives you guys a chance to hydrate. In fact, I'm going to hydrate a little bit more. And we've got about 35 seconds or so left on the ad break, and we can continue. All right. Ads are dead. Okay. So where we were was we were talking about what we need to think about when we are saving a scene, right? So currently our configuration kind of lasts forever, right? But we're going to throw that out after the scene has been loaded. Technically speaking, we could probably throw that out after we've kicked off the load for the scene, right? And so we can't rely on that anyways because it's going to be an out-of-date structure if the hierarchy changes, properties change, like we move something, etc. So we need to, when we're actually loading a scene, there's something we need to keep in mind that we haven't actually discussed yet, which is what the context is of the scene load. And what I mean by that is you are going to load a scene and do different things with a scene that are going to be very different from the context of an editor versus the context of when you're running it in the game's runtime. And so when you load something up in an editor, you're going to be expecting to save that off to disk, right? That means you're going to have to retain certain information about that scene that's loaded, so that way when you go to write it back to disk, you have what you need to actually perform that option or that operation, right? Versus when you're just loading it from runtime and you're not actually expecting to save it. At that point, you don't really have to worry about that, right? Because you're just loading the scene and it's fine. And so, my thought with this is to have sort of a like a scene mode, where we have like maybe like a read-only mode versus a mode that you can actually write to. And if the scene is just read-only, we don't save anything else with it. We don't save any sort of metadata or anything like that. Whereas if a scene is not read-only, then we actually need to store off some metadata along with the nodes in the scene, so that when we go to write those things back out, we have the data that we need. Some of the things that I'm talking about would be like resource names for static meshes, things of that nature, right? There's some of that information that we can get sort of the latest on, like transforms. We can get the latest data on that and write it to disk. Things like directional lights and point lights, those are easy. The skybox has an asset that is used that could potentially change, for the record. And so there are pieces of this that we're going to have to kind of tack on, pieces of metadata that we're going to have to tack onto our scene in order to track this properly. Theoretically, that also means that you could add nodes in, you could delete nodes, and those things need to be managed as well. So if you add nodes in, we're going to have to actually like include the data on those as well, like the metadata. So that's at least my initial thought, right? Are we running this in sort of runtime mode, or are we running it in an editor mode? And I think read-only is going to be the way to do that. Psycode, good to see you. I didn't see you pop up in chat before, but it looks like you've been here a while. Good to see you. Welcome. Okay, so we have scene create, right? So this property probably shouldn't be in the config, is the way I'm thinking about this. And the reason for that is because the configuration itself should not care, right? That's the object that we construct that is read in from disk. So that should be completely separate from sort of our flags that we pass in. Maybe that's the way we do it, right? Because we might actually have other flags that we need to pass in. So maybe we'll create a like a scene flags enumeration, right? And right now we'll basically have just a read-only flag that will either pass or not pass. And then anything beyond that we can actually use, we can just add to that, and then we don't have to change this structure again. So let's go into, so we already have scene state, scene attachment, scene. Let's see, do we have any flags here? We do have it enabled. I don't see any other really Booleans though. Okay. So let's do, I hate using lots of Booleans for things, right? So let's type def, a new enumeration, and we're going to call this scene flags. Or I guess it's going to be, scene flag. Right. And we're only going to have one for right now. I suppose we could do a none. Right, we probably, let's do that. So scene flag none. Right, and we're going to just set that to 0. And then we'll also do a scene flag, oops. We'll do a scene flag read only. Right, and we'll set that to 1. And basically, this one is going to be indicates if the scene can be saved once modified. I.e. read only would be used for runtime. Writing would be used in editor, etc. Right? Let's actually space that out a little bit. So let's do that. And there we go. Okay. So these are going to be bit flags essentially. So I guess I can just go ahead and type def. We'll say U32, and then we'll do we'll call this scene flags. Right. And then we'll just say bitwise flags to be used on scene load, etc. Right? And so here, probably right after ID, honestly, scene flags, and we're just going to say flags. Right? And then when we create the scene, that's where we're going to set that flag, right? So we're going to send a config, then we're going to send scene flags. Right, we'll go ahead and set this up here, flags, and then we'll say flags to be used during creation i.e. read-only, etc. Right? So that's that. And then in scene.c, we'll say scene flags. And then right here at the top, we'll say out scene flags equals flags. All right, so we'll save that off. And then in scene, in the save, after we check the scene itself, the very first thing we're going to do is check to see if scene, which actually, that really needs to be named something else besides just scene. That's actually, before I do that, let's delete this. Let's rename this to just S, right? And then we'll say if s.flags and scene flag read only, right? So if that flag is set, then we're going to say k error cannot save scene that is marked as read only, and we'll return false, right? So we'll get that block in there first. And that read-only flag is going to have a few other roles. So when we actually start loading up all these individual things, for some of these things, we will include metadata with it. So, for example, let's see, the scene nodes. It's going to be under initialize. Scene initialize, scene node initialize is what I'm going to want. Node config. Why do we have this commented out? Is a question. I'm not sure. Is it because we don't actually have on the node a config? Let's see. So we have a node handle. So that's a hierarchy node. So let's see, we have attachments. So when we go to add this, which actually this is some code we have to clean up too. Node config children. Let me just see. Config nodes. So I'm just trying to figure out where to store the metadata, right? Because we don't have anything to like store the names, for example. Which is probably why this is commented out, right? So we do take the xform handle and the node handle. And I think we actually save this stuff directly on the attachments itself. but we're not actually saving like node metadata anywhere. Okay, so we're going to have to create something to hold the node information, all right? Because really, when you think about it, like nodes don't actually exist as a thing in the scene. All a node really is it's a transform, potentially, and a handle into the hierarchy graph, right? So we don't actually, like, there's nothing in the scene that says this is a node, right? Like the node object doesn't actually exist, right? There is no concept of that, right? Because when we process the attachments, we process all the attachments by type at once so that all of those things are grouped together. So we are going to have to potentially now create a little bit of metadata per node. But we only want to do that in the case of not read-only. So maybe we do type def struct, and we'll do scene node metadata, right? For example, the name, right? That's the biggest piece, right? Because all that is within a node configuration right now is essentially a name, transform, children, and attachments. Children and attachments we can look up. The name we cannot, because we're not actually storing that. So we need to have some metadata stored for each node in the scene, so that we can look that up. But we only want to do that. We only want to do that when we're not in read-only mode. So like maybe we do scene node metadata, node metadata, right? We just do an array of these just like we do an array of everything else. So this will be an array of node metadata. And we can actually index this by the node handle, I guess. I think that makes sense, right? So when we are over here, we grab an xform handle and then we grab a node handle, which the node handle is nothing but the hierarchy graph, right? So we could index that way. Although the hierarchy graph is potentially not zero indexed. So we may have to think about that as well. One thing that we're going to have to think about in the node metadata too is if we do it this way, we're going to have to think about, well, what happens when a particular node at a particular index gets deleted? How do we mark this as deleted if it's not like a pointer to that thing? Or do we do this? Right? That seems dirty. So do we have some way to mark the metadata as like this is no longer valid? Or do we create a handle for this too? Not gonna lie, seeing Travis code like this in C makes me also want to code in C. Awesome. That's the hope, right? That is the hope. All right. So I've got to think this one through. So if we take a look at the type, along with this, I suppose we could do kind of like we've done in other places, right? We can have a U32 ID, right? And then say metadata considered stale non-existent if invalid ID. Right, so if that's set to invalid ID, maybe that's how we do it, right? The name of the node. So that would be our way to mark that as not used. Marked as unused by ID equals invalid ID. The only place that this is going to get a little bit weird is if we have, like, whenever we load up a new node or add a node, like, we're going to potentially have to expand this. But I think that should be okay, because we should get a different handle ID from the hierarchy graph, which should be a higher number, which should fit into this. So I guess what we could do is we could just essentially, instead of pushing or using a D array for this, maybe we always just say that the size of this has to be the highest ID plus 1. And then we'll always, as long as we ensure that it's that big a size, we'll always have enough slots, right? So we'll say size of this array is always highest ID plus 1. Does not shrink on node destruction. Okay, so if we have that, then we'll do U32 node metadata count. The number of node metadatas currently allocated. I think that makes sense. Okay. So let me come over here to when we are doing this, we say, let's do B8 is read-only equals s.flags and scene flag read-only is not equal to 0. Just wrap this as well, just to be safe. Okay. And then if is read-only. We'll do that. And then we'll say actually, we should probably move this down a bit. Let's move this. Let's actually move this section after we create the node handle, because we're going to need that to create the metadata. Create metadata at the index of the node. Handles handle index. Handle resize manually to ensure space. And then we can do s node metadata ID equals node handle index, and then s node metadata. This should be node handle index dot ID. But let's not repeat ourselves here. Let's grab this, and we'll say node metadata, C node metadata rather. We'll do M, we'll call that, and we'll take the address of this, and then we'll say MID is equal to handle index, and then M name equals that. Right? Okay. And this is basically how we're going to handle the metadata for nodes. We're also going to have to do this for attachments. Also do this for attachments where needed, right? So only some attachments are going to need that. I know I broke where the scene is actually loaded. Resource system. All right. So we do not have resource system right. Because that tries to do the load thing. I think for right now, I want to leave that in place because I do want to handle this differently. But we're going to say, we're going to just throw an assertion for now. Resource system right not implemented. We want to handle this differently. To handle this differently. Maybe a resource writer. Ooh, that's good, actually. We have a resource loader and a resource writer. That's probably what we're going to do. That makes a lot more sense to split it up that way. Okay. Taman, good night. Glad to see you here. TCAP, how's it going, bud? Good to see you. I'm just wrapping things up for tonight myself here. So let's see, testbed main. So okay. So when we're loading the main scene, I'm gonna do. We need scene flags, right? So we need scene flags. We'll say scene load flags. And we're just going to set this. You know what? I'm going to do it this way just to make it a little bit more clear. Scene load flags or equals scene flag read only, right? Which that's not. This really isn't temporary anymore, so I can get rid of that one. Create the scene. Note to disable editor mode. Turn this flag off. Right? And then we pass our flags. Scene load flags here. Right? And I'm actually going to comment this out for right now. And I'm going to comment that out because I actually don't, well, you know what? I do want read-only mode right now. It means you're really not going to be able to run this yet if you pull this code. So if you guys do pull this branch, you're going to want to turn that flag off. But I don't want to forget that I did that and then wonder why it's not working later. By the way, if you guys aren't following TCAP, definitely do. He's always working on cool stuff on his channel. There we go. Shout out to TCAP. All right. Yeah, definitely go give him a follow if you're not currently. First time chat, Money Boy. Hey, how's it going? Good to see you. He's always working except for when he isn't. I know that feeling. I know that feeling very well. All right. So it runs. It's probably going to poop itself. It's probably going to segfault actually. Because I have that flag on, it's probably gonna not like that, and it's gonna try and write the name off somewhere that it doesn't actually have. Yeah, exactly. Yep. All right. So in theory, I should be able to disable this. Let me just make sure that this actually does the thing. Yeah, okay. So I'm going to re-enable this. And if anybody is actually pulling this, trying to run it, just know that you have to turn that flag off in this current state. All right, so let's see, to do. We can cross off anything here. All right, let's see. We actually still have all this stuff to do to convert these all to use handles as well. Okay. We don't have anything here that we can actually... update yet. So what we'll do, and we're actually working, this is all what we're working towards, by the way. This entire thing was caused by this one bullet point. Change log. So let's see. A couple things I need to mention here. Fixed an issue where dearrays could be initialized to a different type than what was actually being assigned. All right, so that was a bug we fixed. And then also, did we actually not put the case in parser in here at all? Wow, really? That's kind of a big thing. Added custom storage format. Complete with tokenizer parser. Converted scenes to use new case and storage format. Nitrix Dev, I like that one. You have a question. Go for it. Ask before we end the stream. All right, so added flags to scene load. Can flag as read only versus editor mode, etc. Okay. So we'll get to the metadata next time, so that we can actually store off the metadata that we need to store. And then from there, we will be able to have all the data that we need to actually write back out the scene, right? And write the serializers and all that stuff. Okay. I'm going to save my session here, and so there's the stuff we changed tonight. So we're going to say scene loading from casein complete. Deserialization also complete. Added scene flags to scene creates. Spiro with a rate of 17 viewers. Thanks, buddy. What's going on? Oh man, your timing is impeccable, because I am literally finishing up the stream at the moment. I was just about to raid you too. What's happening, dude? What did you get up to on stream? Thank you for the raid, by the way. And actually, I was about to give you a shout out as well. So if you guys aren't following Spiro, definitely do so. Guy's a madman. He's creating all kinds of cool stuff on his stream. He's using the DOM as the renderer front end of his engine, FYI. Let's see. Oh no, are you guys posting links? My bot deletes link posts. Sorry about that, guys. I wish I could keep raiding for another hour, but I do have to get up and go to work. You went full degenerate last 15 minutes? That's awesome. Yes, I am using NeoVim. Yep. Well, welcome, raiders. So I guess... Your raid message got everybody timed out. What was the raid message? Out of curiosity. Best way to end a stream. Yeah, I agree, Axelot. Yep. We did that the other day on here. We were chasing an issue for like 4 hours the other day. Memory issues. There was a period between two words and it considered it a link. Yup. Womp womp. Spiro had my sides absolutely killing me. It was hilarious. Yes. He's good at that. Oh, it was the I'm sorry I cannot assist with that request. Because there's a request that pretending it probably like parsed that as. I wonder why it did it for some of you and not others. Weird. Pretending a human on Twitch chat is illegal and highly dangerous, poses serious risks to life and prosperity, and it's against ethical and legal principles to engage in such act. Was this written by ChatGPT by chance? ChatGPT? It seems very ChatGPT-like. Oh, okay. Okay. It was a post from somebody earlier in your chat. Okay, that makes sense. That's funny. That's super funny. All right, well, so our ads are actually going to kick off in like 2 minutes. So I will give you guys a really quick overview as to what we're working on here. I am shutting down the stream, but we'll talk about this really quickly just so you guys at least know what we do here. So I'm making something called the Kohi Game Engine, which is a game engine we're making from scratch, completely in C, and using Vulkan as our initial rendering backend. I say initial rendering backend because we're going to support multiples. So Vulkan's the first one. We're also going to support Direct3D. We're also going to support Metal. OpenGL maybe, probably not. So it started off as a YouTube series, as like a tutorial series, and then we kind of just outgrew that format and eventually changed formats a few times and wound up live streaming here on Twitch. So Axelot, thank you for the 6 months of tier 1 sub. I appreciate that a lot, buddy. Thank you very much. I really appreciate that support. Thank you. That means a lot. Thank you. And so basically what we do here is we're just developing the whole thing on stream, right? It is cross-platform, so it's available on Windows, Linux, and Mac OS. It is eventually going to work on mobile as well, so I have plans to port it to iOS and Android as well at some point. It is royalty-free, meaning there's no licensing fees of any kind. We'll get to that in a second. It's open source, so we can go here to our GitHub, and that's the link I dropped in chat. And it is Apache 2.0 licensed, which basically means if you want to use the code for commercial or personal, does not matter. All that I ask is to say that you use the code. Literally just, hey, by the way, I use Kohi. That's it. That's all I require, right? There will never be any sort of licensing fees or royalties of any kind. It's all 100% free. And yeah, well, we don't paywall anything. We do have like a Patreon and that kind of stuff, but it's literally just a way to support what I'm doing. It doesn't actually buy you anything extra because I think that education should be free and available to everybody. And so I don't paywall any of it. All of it is available completely for free. That includes what we do here on Twitch and also what we have on YouTube, as well as the Discord server, which is around 900 people, I think, at the moment. So that is the quick and dirty introduction, by the way. And we do have a Twitch stream there at the bottom on the site. So that is more or less it. And yeah, we're going to have ads here in another 10 seconds. So I will probably end the stream after ads so that you guys don't wind up having like a raid in the middle of ads, because that's weird, right? So yeah, basically what Travis is saying is that he's a Giga Chad. Not as much as Spiro, though. Spiro takes the cake. Spiro is the Giga Chad of Giga Chads. Thank you guys for the follows, by the way. I really appreciate that. So yeah, we have ads starting soon. So I just paused the stream for the 90 seconds that those ads run. so that nobody misses any content. Too many chads. Why can't I hold all these chads? That's hilarious. Unfortunately, I do have to work in the morning, so I can't keep going. Oh, the ads finally kicked off. Twitch sometimes tells me late that the ads came up, which is kind of annoying. I really want to automate that. Maybe that's something I'll build on stream at some point. Is like automatic ad detection so that I can just have it tell my OBS to flip to that scene immediately. That'd be neat. So I'll just wait for the ads to complete. Well, Spiro, I thought I knew how I was going to raid, because I thought you were still streaming. But unfortunately, you are not online. So, I cannot return the favor. But thank you for the raid. I really do appreciate it. Almost done with ads. Just a few seconds left on ads. And we'll be good to go. All right, cool. Ads are done. So yeah, that's pretty much it. I would just encourage you guys, if you haven't already, follow me on either side, over on the YouTube side or on the Twitch side, just so that you guys will get notified when I go live tomorrow, because I am going to be streaming tomorrow night as well. So we're going to pick up where we left off tomorrow night, which is going to be serialization of the game scene to our new custom format, which we wrote the parser for ourselves, right? So we're going to pick up on that tomorrow and hopefully get that done. We should do both. Let's see. Okay. Who am I going to raid? Let me just pick a channel real quick. You know what? I actually have not raided this person before. And they are releasing their game very soon. I think in like the next week, his game is coming out. So we are going to raid Sundown. And they are making a game that, like I said, is coming out. I guess they're working on their final boss fight now. Spoiler alert. But we're going to raid him anyway. So thank you guys so much for being here with me. And thank you, Spiro, again for the raid. Sorry about the raid and you know, and close down, I guess. But it is what it is. I've got to get up early in the morning. So, but yeah, I will see you guys tomorrow night, 9 p.m. EST, or EDT, I guess it is now, is the official starting time. I might start a little bit earlier than that. We'll see. But yeah, thank you for the follow, and I will see you guys later. See ya.